So right now I want to talk about transformations. And this section has, let's see here, 15, 19, 37, 49, and 55. This section, it can get out of hand, so you really got to be careful with this one. So we're going to do vertical and horizontal. Stretches and shifts, and we're also going to do reflections. I'd like for you to work through examples 1 through 5. Okay, so I'm just going to start with a big, nasty table of transformations. So we're going to say given a function, let's call it f of x, and a positive constant c, we're going to try to do, let's see if we can get 10 things listed off here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, cool. That kind of worked. And what do we have? So let's try to set this up. So here's the effect on the graph. Of f, and here's the transformation on the function. So if I shift up by c, then I do f of x plus c. So that makes sense. If you increase by c, you lift it up by c. Shift down by c, okay, not surprising, f of x minus c. All right, now here's the first sort of weird one. Shift left by c, so to the left is going to be f of x plus c. Now that might seem backwards, like wait, to the left is subtracting, but I want you to think of this as, let's, for the horizontal shifts, the shifts left and right, I want you to think of the function as like a movie reel. And if something happens earlier in the movie, then it's happening further to the left. Okay. Shift right by c. That's going to be f of x minus c. All right, so that might seem a little counterintuitive, but just go with it. Now, if we do vertical stretch by, we're going to have c greater than 1. Whoops, that's true, but vertical stretch by c is going to be c f of x with c greater than 1. C is definitely greater than 0, as I defined it, but if it's a stretch, c is going to be greater than 1. Now, if we do a vertical compression by c, we're going to do cf of x, but here c is less than 1. And we already said c was positive, so maybe let me emphasize this by saying c is going to be between 0 and 1. Okay? We can do a vertical reflection, and that's if we just do minus f of x, that just flips it over the x-axis. We can do horizontal compression by c, and that's going to be cf of x. Now again, hold on a second. If I watch a video at twice the speed, not cf of x, f of cx. If I watch a video at twice the speed, is it going to take twice as much time or half the time? It's going to take half the time. So a compression is going to happen when c is bigger than 1. Now a horizontal stretch by c is going to be f of cx when 0 is less than c is less than 1. Finally, a horizontal reflection is going to be f of minus x. Now, from our discussion on even and odd functions, we know that a horizontal reflection we won't see a horizontal reflection for an even function. Let me fix this up a little bit here. This is getting a little too hard to read. Let's just clean you up a little bit. Horizontal reflection. Okay, so let's do some examples. So hopefully you can write that table down. You can, it's a video, so you can pause it and go back. So let's do one example, which is going to be, let's consider G as a transformation of F. And let's describe the transformation. So we're going to let f of x equal just x squared, and we're going to let g of x equal 3x minus 1 quantity squared plus 2. And let's describe the transformation. So we start with, there are a number of ways to do this, but what I want to do is I want to start with f of x. So I start with f of x. And this is just x squared. Okay? Now, what if I do, if I start doing stuff to f of x, let's do 3f of x. So this is going to be 3x squared, and this is going to be a vertical stretch, right? Because I'm multiplying by something bigger than 1. Now I want to take this thing and shift it to the right by 1, so 3f of x minus 1 is going to be 3, and then quantity x minus 1 squared. And this is a shift right by 1. And finally, let's shift it up by 2, so we're going to do 3f of x minus 1 plus 2. So this is 3 x minus 1 quantity squared plus 2, and this is shift up by 2. So what did we do? Our final answer is a vertical stretch, a vertical stretch by 3, factor of 3. We stretched it vertically, we shifted it to the right, and then we shifted it up. So that's just reading off of this chart here. I know it's awkward in this video because we can only see one thing at a time, but let's now look at this graphically. So here's f of x, and this is a parabola. Now when we do 3f of x, we're gonna stretch it vertically. So instead of this nice, what we have here, this nice round parabola, I'm just gonna exaggerate and make the parabola taller and skinnier. Okay? Now, at first blush, you might be like, wait, shouldn't 3 make it bigger? Shouldn't it get wider? But it should not get wider, because what's happening is each value is being lifted up. So initially, this value at 1 was like here, and now this value at 1 is 3 times higher. Okay? So this should be the same basic shape, but just stretched up. All right, fine. So now let's do shift to the right. This is going to be the same thing, same sort of tall, skinny parabola, but now shifted to the right by 1. So this is 3f of, keep wanting to throw that parenthesis in early, 3f of x minus 1. And finally, let's shift it up by 2. So it's to the right by 1, we're going up by 2, and it's a nice skinny parabola. This is 3f of x minus 1, all plus 2, and that's our g of x. So there's a vertical stretch by a factor of 3, shift to the right by 1, shift up by 2. All right. I want to give you just a word of advice. If you are, if you're doing this, just be sure that you keep your multiplication and your adding in order. So I would multiply first, then add. You notice how I did this multiplication action before I did the addition action, because if I added something and then did the multiplication, I would have to multiply this added thing as well. So you have to be careful about that. I would say try to do the multiplication before you do the adding in general, with both for vertical and for horizontal. All right, let's do another type of example. Suppose 3, 2 is on the graph of f of x. Where is the corresponding point on the graph of what? Let's do 1/2 f of 3x plus 1. Okay, now what do I mean by corresponding point? I mean, I don't know what f of x is, right? Okay, I don't know what the graph of f of x is going to look like, but I know that this point 3, 2. You know, let me work with some cleaner axes here. Problem is these don't always line up with the lines exactly. So the point 3, 2. So there's 3, there's 2. This is on f of x. I don't know anything else about, you know, where this graph is going. I don't know what this function looks like. I just know that 3, 2 is somewhere on the graph. Now let's go step by step and try to figure out where this point travels to. So this is 3, 2. Now for me, I actually I'm gonna take this and cheat here. I don't need this picture so much as I like to how to say this? I don't know how much you need the picture so much as you need to write down the coordinates of the point. Okay, so as this is going, you know, I'm gonna keep drawing the picture to reinforce that this is moving, you know, what's happening graphically, but also when I do these, I often just keep track of the coordinates of the point. Okay, I'm gonna start by doing half f of x. So I'm gonna cut the y value in half. So now where I was at 3, 2, I'm gonna be at 3, 1. Okay. Next, just try to kind of line that up. Next thing I want to do is I want to shift it up by 1. Okay, so I'm going to do 1/2 f of x plus 1. And so we're back up at 3, 2. All right, so I cut it in half and then shift it up by 1. So I'm back at the same point, but for weird reasons. Okay, almost done now. The last transformation. Okay, can I move you? Please, please. The last transformation is going to be, we're putting it all together, 1/2 f of 3x plus 1. So this is going to be a horizontal transformation. So I know I'm not changing vertically. I'm going to keep the same. I'm going to keep the same y coordinate. So it's something, 2. But what happens if I multiply the inside by 3? Let's go back here and look. If I multiply by a constant that's bigger than 1, we're going to compress by that factor. Again, I want you to think, if I'm watching a hilarious YouTube video and something happens at minute 3, right? What happens if I watch that video 3 times as fast? It'll happen at minute 1. It's going to happen in a third of the time. So this is 1, 2. And this is the point that corresponds to 3, 2 in the graph of this new function. Okay, so your final answer here is 1, 2. All right, again, try to do the multiplicative stuff before you do the additive stuff, or at least keep consistent and make sure you understand what's happening, and try to do some examples. Thanks so much.